Here we need to take the derivative of this function. We'll use the product rule and the chain rule. We'll use the product rule because we've got two factors, and each of those factors are binomial factors, one of which is cubed, other is squared. So that's why we need the chain rule as well. So we'll start with the product rule. The derivative with respect to x. We'll write out the second factor first. So we've got 1 minus x to the fifth squared. And then we'll multiply by the derivative of the first factor. So using the chain rule, we'll bring the 3 down in front. We'll rewrite the inside. Reduce the power by 1, so now it's squared, and then we'll multiply by the derivative of the inside of that factor there, which is 4. Now we'll put a plus sign here, and we'll reverse that order to get the next term. So now we're going to rewrite the first factor, which is this 4x minus 3 cubed. And we'll multiply by the derivative of the second factor, which again, we'll use the chain rule for that. So the 2 is going to come down. We'll rewrite the inside. Reduce the power by 1, so now it's to the first, and then we'll multiply by the derivative of the inside, which is negative 5x to the fourth. So this here is our derivative. Now, as far as what you got to do before inputting it into the MyLab Math, all you really have to do, at the least, I would say, is to we'll combine these coefficient factors. So you got a 3 and a 4 is going to make 12. We'll put that out front. We've got here 4x minus 3 squared still. And then we've just got this 2 and negative 5 to combine. So that's going to make this plus sign negative. 2 times negative 5, you can think of it as positive 2 if you want, but because we've got a plus here, 2 times negative 5 is negative 10. And then we'll put this x to the fourth out front just because it looks nice to have it there as the first factor written. And then we still have this 4x minus 3 cubed and 1 minus x to the fifth. This would be sufficient as an answer here. It's even possible, depending on how you interpret the product rule, that you might even have one or both of these factors here rearranged within the terms. It doesn't change anything. It's like saying 3 times 5 versus 5 times 3. So there's perhaps more than one way to answer this, and it would be sufficient. This should, I'd be very surprised to find that you put this into MyLab Math right here, and it marks it wrong. It should be a good enough answer. Now, if the goal is to factor it further, and if you get the question wrong in particular, MyLab Math is likely to give you the correct answer in factored form. But that doesn't mean that's the only form it will take. But to go further, to produce a fully factored answer, we can begin with the idea there's two terms here. So we've got terms are separated by pluses, minuses, and equal signs. Terms add and subtract. So this is all one term here. Within this term, we've got the 12. We've got this does not make up a new term, this negative sign here, because it's tied in as part of what's called a binomial factor. Right? This whole thing is multiplying. And in fact, it's a binomial factor squared. So this does not make a new factor. We got 12. We've got 2 of these binomial factors here, and then we've got another binomial factor in 4x minus 3 that's squared. So this is all one term. The second term's over here. And again, it's got the 10x to the fourth, and it's got these 2 binomial factors in it. So 2 terms in this expression here. And if we want to get it simplified, we can first look for a common factor across those 2 terms. And we'll begin with the coefficients. So we got 12 and 10. So if we consider what's common between 12 and 10, well, we got a common factor of 2. So I'll write the 2. Now we'll move on to this binomial factor 1 minus x to the fifth. In this first term, we have two of them because it's being squared. In the second term over here, we've only got one of them because it's being raised to the first. So as far as what's common to both, what we can pull out, we can only pull out one factor of 1 minus x to the fifth. Another way to think of this is pull out the smallest exponent across the two factors, right? So 1 minus x to the fifth to the first. So we're only going to pull out one of them. Now we can move on to the next binomial factor, which is 4x minus 3. And using the same idea, there's two of them here, squared, and there's three of those binomial factors in the second term. So at the very most, we can pull out two. So we'll write this as 4x minus 3 squared. And this here is the greatest common factor. So now what's left is we'll put in parentheses, we'll write up what's left of those two terms, having factored out the greatest common factor. So we pulled a 2 out of this 12, so that's going to leave behind a 6. We pulled out one factor of 1 minus x to the fifth, so that's going to leave behind another factor since it was squared in this term. So we'll raise to the first now. We pulled out both factors of 4x minus 3 from this term. We pulled out two factors of it, so it's squared, which means we have none of them left in this first term. So this is what's left in that first term. Moving on to the next term here, we had pulled out a 2, so that's going to leave behind a minus 5. We didn't pull out any x's, so we'll leave the x to the fourth here. 4x minus 3, well, there was 3 of them in this term, and we had pulled out 2 of them as part of our greatest common factor. So we still have 1 left over, 4x minus 3. And then we pulled out this 1 minus x to the fifth in our greatest common factor, so this is completely gone. So now we have the greatest common factor pulled out. We got this piece almost simplified. The last thing to do here would be to distribute the 6 and the negative 5 across these binomial factors and then combine like terms. So we could, if we multiply the 6 in, we're going to get 6 times 1 is 6. 6 times negative x to the fifth is negative 6x to the fifth. Then we've got a negative 5 to distribute in with this 4, so that gives us negative 20. X to the fourth times x is x to the fifth. And then negative 5 times negative 3 is positive 15. X to the fourth. So we distributed, and now we'll just combine the two like terms here, which is the negative, it'll end up being negative 26 x to the fifth. And how you arrange these three terms can really depend on really who's doing the problem. Doesn't really matter. You could argue that maybe we'll put the leading term out front and then factor out a negative since it's going to be negative, but it shouldn't matter at all. I'll leave the 6 here since that's where it was already oriented. You could put minus 26 now, or we could put the 15x to the fourth in, and then we'll write this minus 26x to the fifth. And we just combine like terms. And like I said, it's feasible to rearrange these terms in different orders. It really doesn't necessarily mean one is better than the other. So the final answer here would be, we'll just pull that greatest common factor that we had factored out. We'll put it in front. And this is likely to be, if you get the question wrong, this is likely to be what MyLab Plus suggests is the answer. But as I said, there's potentially more than one form that's going to work. And it should be the case that it would take this up here. If you plug that in exactly as it's written, it should mark it correct. Moving forward with the course, factoring is not going to be, this is probably the most factoring you have to do across the whole course. A lot of the factoring that ends up happening is we work a lot with just basic trinomials. So an example is, I'll just write something up. Let's see. let's just say we needed to solve this equation. So it's not so much even the factoring that is the point. It's if we needed to solve something like this, if we needed to set this equal to 0, you could use the quadratic formula to get it done, but one convenient way would be to factor it. They call this reverse FOIL a lot of times when people first learn some factoring, where you look at the first term and you break it up into its factors. So the way you break down x squared is x times x. And then we consider the factors of the last term, which is 6. Since it's a positive 6, we want these factors to add together to give us the middle. So we'll consider 6 and 1. If we do -6 and -1, they multiply to give us positive 6, and they also add together to give us the -7. And then we could set each of the factors equal to 0 to find the solutions. So that's really the extent of the factoring as far as this course cares about. This problem here definitely involved some algebra, so good question. This question was definitely a lot of algebra. So you could say again, maybe this is the best answer here, but it should take this one in green. If you have any other questions, let me know. Thanks for the question, and hopefully you found that helpful. Thanks. Bye.